Today we are going to study the refraction through the glass prism. What is a prism? It is the first question which should come in your mind after listening the topic. A prism is basically a refractive medium bounded by at least two non-parallel refracting surfaces. But the most simple prism we have taken and we have normally observed in the labs is that in which there are three rectangular, here the cursor is showing three rectangular non-parallel surfaces and two triangular surfaces. These triangular surfaces are parallel to each other and the three rectangular surfaces are non-parallel to each other. This angle is called the angle of prism, and it depends that the angle is very less or big or the prism is equilateral, and accordingly the properties of prism changes. Now, if this edge you can see, this edge is called refracting edge of the prism, and these surfaces through which the light ray refracts are called the refracting surface. Now, if the prism is on this side, it is upright, then it is called the base. Now, we want to study that how the light ray behaves when it falls through a prism and go through it. So, let's have another diagram in which we can show that how the light ray falls and behaves when it goes through a prism. Here, this ray AB, which is the ray which falls on the surface small BA. This is the refracting surface of the prism, and when the incident light AB falls on it, it undergoes the process of refraction. This blue line is showing the normal, which is perpendicular on the surface of the prism, and the light ray which is incidenting and the light ray which is refracting, that is BC, is actually refracting at an angle which we have named R1. Now, if we go through further, then BC light ray propagates and reach up to the second refracting surface, which is small AC. Now, at this refracting surface, the light ray again it suffers through the refraction, and here when the light ray is coming outside the prism, it again bends and go through emergent angle which is denoted by small a. Now, these refractions mathematically, and here first of all, as we have gone through the process, so the ray AB, when it falls on the surface AB, then it actually is moving from air to the glass medium, and as we know that the glass is optically denser than the air, so the light ray AB bends towards the normal, and the angle of refraction for the surface AB, it is R1. But when the BC light ray propagates and reach to the surface AC, then it bends away from the normal as it is moving from glass to air, and when the light ray travels from denser medium to rarer medium, it bends away from the normal and the incidence angle is lesser than the refracted angle in this case. So, now we want to calculate that what is the relationship between the angle of deviation and the angle of incidence and angle of emergence and the refracted angles. So to find the angle of deviation's numerical expression, first of all we should know that what is the angle of deviation. Angle of deviation is calculated between the original direction of the incident ray and the refracted ray. So we can define angle of deviation as the angle between the original direction of incident ray, which is in the diagram at surface AB. It is shown by the ray BE, the line BE. Now AB is the incident ray and BE is the showing the original direction of incident ray. But when we talk about the refracted ray, then refracted ray is BC. So here the angle of deviation is delta 1, which is angle MBC. Now this is the angle of deviation, as it is telling us that how much the light ray has been deviated from its path while it is moving through the interface of the air and the glass medium. So here in the diagram we can say that angle of deviation, which is denoted by angle MBC, is equal to angle NBA minus angle CBO. Now, how we have written this mathematical expression? You can see from the diagram that this angle, which is denoted by I, it is the angle of incidence, and here this angle is actually sharing the vertically opposite angles. That is, if you want to see, then this angle is having a vertically opposite pair with this angle. Now if we are saying that this delta 1 and R1 are combining, showing that vertical opposite pair of I, then delta 1 can be written as angle I minus angle R1. So we are getting the value of delta 1. Delta 1 is equal to angle NBA in the diagram is showing angle I, and minus angle CBO is denoting the refracting angle, and it is for the first surface, it is denoted by R1. So this is our equation 1. Now let's discuss that how delta 2 can be expressed in terms of E and R2. This R2 is the angle of incidence if we are taking the light ray moving from glass prism to the air outside. Now this R1 is the incident ray and E is the emergent angle. Now if you can see again, then similarly as the last process, angle E is equivalent to delta 2 plus R2, which is the angle of, which are the two angles of vertically opposite pairs. Now here also we can write that angle MCB is equal to MCB in the diagram. Here the cursor is showing that angle M, C and B. It is the angle of deviation, which is the angle between the refracted ray and the incident ray's direction. So this is the angle which is showing that how much the refracted ray has been deviated from its original path. So angle MCB is equal to angle N-CD minus angle OCB. When we are going to write it in the terms of the same symbols we have used, then angle MCB is denoted by delta 2 and it is equal to E minus angle OCB is denoted by R2. So we have observed this is our equation number 2. Now, if we see that in the whole process of these two refractions, if we totally find out the angle of deviation, then it will be the angle between the incident ray which was the original incident ray, and it is BE is the original incident direction, and the finally reflected ray that is CD, when it is extrapolated back, then it coincides with the original direction of the incident ray at M. So the angle between the original direction of incident ray and the refracted ray's direction, it is giving us the angle of deviation. That's why here it is the total deviation which is in between the original incident ray direction and the finally emergent ray's direction. So guys, to get the value of I of R1 and R2 in terms of angle of prism, let's see the quadrilateral which is formed in the above diagram closely. It is the angle of prism A. This is the edge. It is the vertex A, small a, and the B point is the point of incidence, and O is actually that point at which the normal meets. C is again the point which is the point of incidence for the second surface, and here delta 1 and delta 2 are the two angles which are the deviation angles, and R1 and R2 are the two angles which are inside the prism, and one is the refracted angle and second is incident angle for the second surface. Delta is the angle of deviation. Now we are going to calculate the value of R1 and R2 in terms of A. In the quadrilateral, small a, capital B, O, C, we can write that angle A plus angle ABO plus angle OCA plus angle BOC are the four angles of the quadrilateral, and the four angle sum for a quadrilateral, it is equal to 360 degree, right? So we can write it as that the opposite angles here at this point, as the blue line, the blue dotted line is showing the normal. That's why if we extend this line, then you can clearly see that as the normal is perpendicular on the surface, thus if this angle is 90 degree, then similarly this angle should be 90 degree. So angle ABO and angle ACO, that is, we are saying that angle small a B O is equals to angle AC, angle ACO is equals to 90 degree, because these are formed by the normal and the prism surface, and normals NO and NO dash are perpendicular to the surfaces. So this is the clear, simple logic of taking the angle ABO and ACO as 90 degree. So students, let's recall that what we have done in the last few minutes. We have to find out the value of R1 and R2 in terms of some known angles. So we are doing the exercise, mathematical exercise in the quadrilateral ABOC, and as the 4 angle sum for the quadrilateral is equal to 360 degree, so we have written this equation. Now angle ABO and angle ACO comes equal to 90 degree because they are formed by the normals and the surface of the prism. Alright, now if we are saying that angle ABO and angle ACO is equal to 90 degree, then we should use this information. Say it is the equation. So first of all, this equation is 4 and we are numbering it 5. Then using the information from 5, we put these values in equation 4 and we'll get that angle A, that is the angle of prism, plus 90 degree plus 90 degree is equals to angle BOC, angle A plus 90 degree plus 90 degree, angle BOC, and all the sum is equal to 360 degree. And we can again write that angle of prism plus angle BOC should be equals to 180 degree. This is our equation number 6. So one equation we have got in terms of angle A and angle BOC. Now if we observe this triangle angle BCO, then in triangle BCO, by the triangle property that the 3 angles of the triangle always makes the combination equal to 180 degree, then we can write here in this with this diagram we can have angle R1 plus angle R2 plus angle O should be equal to 180 degree. Let's write it here. R1 plus R2 plus angle BOC is equal to 180 degree. This is equation 7, and the equation 7 has the logic triangle sum property of mathematics. Triangle sum property says that all the 3 angles, the sum of all the 3 angles should be equal to 180 degree. So when we compare the equations 6 and 7, then the RHS of both the equations are same. That's why we should write angle A plus angle BOC, that is the left hand side of equation 6 should be equals to left hand side of equation 7, which is R1 plus R2 plus angle BOC. As angle BOC is common in both the sides, so we can make it adjust with each other, and that's why we are remained with the angle A is equals to R1 plus R2, where angle A is what? We have observed that it is the angle of prism, which you can measure simply by taking the prism. So we are in equation 8. We have got the value for which we are doing the whole exercises. Now if we go that what is the significance of this value, then we should here we have a relationship which we have already derived between the angle of deviation delta and angle of incidence and angle of emergence I and E, and the 2 angles R1 plus R2 which we got inside the prism. If we put the R1 plus R2 value, which is equivalent to angle of prism, as we know that we have angle R1 plus R2 is equal to angle of prism, so we can use this value in this equation and can get the result. So since delta is equal to I plus E minus of sum of R1 plus R2. So if we put the value from equation 8, it comes equal to I plus E minus angle of prism. This combination is equivalent to the angle of deviation, and we can write it as delta plus A is equals to I plus E. So it is the result for which we have done all the mathematical exercises here, and it is of much use in the optics related to prism. Let's have a numerical. So we have the numerical in which we are given that a ray of light is passing through a glass prism. So we can make a diagram here. Here is a glass prism, and a light ray is moving through it such that angle I is equivalent to angle E. This is the incident ray, this is the first refracted ray, and it is the second refracted ray. And for the normals, let's have a different color. So the normal N, and here the normal is N dash. This angle is the angle of incidence, and this angle is the angle of emergence. And this question says that angle I is equals to angle E here. So again, if we come to the diagram, then it is given that angle of prism is equivalent to 30 degree. That is given in the question. Also we have given that angle E is equals to 3/4 of angle of prism. So angle of prism is given as the 30 degree value. So let's put the value 30 degree. Now we have the two informations. If I is equals to angle of emergence, and the second information we have that the angle of emergence is equivalent to 3/4 of angle of prism, that is 30 degree. Now let's solve this question. As we know that delta plus A is equal to I plus E. Delta is angle of deviation, A is angle of prism, I is angle of incidence, and E is angle of emergence. From equation 1, or the given information that I and E are equal, we can write it as delta plus A is equals to twice of angle of emergence. But as we know from equation 2 that angle of emergence is equivalent to 3/4 of angle of prism, that is equivalent to 30 degree. If we solve this value, we'll come to the value 2 into 30, 3/4 into 30 degree, it is equivalent to this value comes equals to 1.5 into 30 degree. So when we have to find the angle of deviation value, then we should write it as 45 degree minus A sent to the RHS, and it is equal to minus of 30 degree. So delta comes equals to 15 degree. This is what we have to got.